Hello and welcome to Developing on iOS. My name is Mikk and I'm an iOS developer in high mobility. Today I'll show you how to get started with the iOS SDKs in the Mercedes-Benz Digital Challenge, and I'll be making a small sample app that connects to the emulator. First, we connect using Bluetooth and later using telematics. So let's get started by creating our Xcode project. I will name my application and save it. To get started, I'll first need to download the frameworks. To do this, I will go to the Developer Center, go to Downloads, and there I can see the iOS frameworks. I will download them, unpack, and drag them to the embedded binaries. Here we can see three frameworks. The Auto API one is used to help you parse the Auto API responses and make the commands. The alternative is to combine the bytes yourself. The HM Crypto framework is to secure the communications, and the HM Kit framework is the main one that handles all the communications and the protocols. Let's start by importing the HM Kit. In HM Kit, our main class that we use is local device. The local device represents the device that your app is running on. And to get started, we have to initialize it. So we see that it requires three arguments: device certificate, device private key, and issuer public key. To get them, I will go back to the Developer Center. I will go to Develop, and I will create a new application. And I will create a device certificate for my device. Choose it and copy the initialize snippet. Now, this is done. We have successfully initialized our snippet. I will add some logging to the console so that I can get more feedback. This is an option set that I can choose what logs do I want. I'll just choose the basic ones. Next thing to do is to set the delegate for the local device. And I'll set it to the view controller. Now I'm going to get an error that I haven't implemented the methods, so let's do this. Here we will have three methods: with loose link, the receive link, and state change. The last one is most obvious. This is called when the local device's state changes. And for feedback, we just log it out. So next one is did receive link. The link is a connection to the vehicle. So to handle that, we'll set the delegate. And when we lose the link, we'll remove the delegate. Now I have the same error as with the local device before. meaning I have to implement links delegate. This one also has 3 methods, but different ones. Did receive command, that's when the vehicle sends us some data. We'll just log it out for now. And we'll make it human readable. Next, state the change, again, pretty obvious. Finally, did receive authorization request. So this is called when first time connecting to a vehicle. This is called to authorize the connection. So after it's been authorized once, it doesn't get called anymore unless the authorization has been revoked. So, and as you can see, there's an approve block that we can call to approve the authorization. This can be useful if you'd like to ask the user for authorization. So we'll check the signature of this one. As we can see, it's a really simple function that throws. So we'll have to call it in a to-catch block. Okay. So for our app to actually do anything, let's give us some feedback. If we have an authenticated connection, let's change the app's background. Okay, very simple feedback. But how to get the connection visible or the device visible to the vehicle? For this, we need to start broadcasting. Let's make a button that lets us do that. So we'll access the singleton and find the method we're interested in. Start broadcasting. As you can see, it's a throwing method, so obviously we need to wrap it. And again, to give us some visual feedback, we'll change the background color if the broadcasting started successfully. Let's go yellow. Now we need to make a button in the interface builder. Just simple one. Spell it correctly. connect it up. Yes, let's run that. While it's building that, we'll also need to find the emulator. We'll go back to the Developer Center, to the Develop tab again. We'll go to Virtual Cars, and we'll create a new car. Perfect. Okay, so now we'll tap the broadcasting button. We can see that it was started successfully. In the emulator, we'll scan for it, and here we can see our device. When we pair it, we can see it pops up in the linked apps column. By clicking it, we can authorize the connection. Now we have an authorized connection. Perfect. So, next, we'll actually want to do something with the authorized connection. So let's turn on the lights. To do this, I will again make a button in the UI and the method for it. Turn on the lights. So we'll need to find a link to send the command to. To do this, let's go through the singleton. Of course, we can always save the link in an instance variable in the local device delegate, but I'll do it like this. And we're interested in the authenticated link. Perfect. Okay, now we have the link to send the lights command to. Now we just need the command, or the bytes for the command. To do this, we could manually write down the bytes and send them, but because we have the Auto API framework, we'll instead use that one. So let's find the lights command and the control lights bytes. So this has 4 inputs: front exterior light state, full beam, others active, and the ambient light color, let's just use white. Okay, now we have the link that we want to send the command to, and we have the bytes for the command. Send command. This again throws. And if it failed to send, we'll log out the error. Excellent. Also, because most Auto API commands, they send a response of the new state. So to see what the response is, we'll create the method that parses the incoming data. and I like to use generics for that. Okay. So we'll head back to the link delegate command that sent us the command bytes, and we'll just forward those bytes to the parser. Okay. And now let's build out the parse response command as well. To parse the auto API commands, it's simple. We'll just call the static method on the auto API. And as it returns an optional, then we'll try to get it. If the parsing wasn't successful, let's give us some feedback. Okay. And because we know that we're sending out lights command, then we can expect to receive a lights command response. So to see if it's the one we're expecting, let's see if we can cast it. The response that we got from the parsing is a structure that has identifier that shows the command's ID and the value. So we'll try to cast the value as lights command response. And if it's not that one, let's just say so. But if we did manage to get the right response back, let's just give us some feedback. And if we look at the structure, you can see it has basically the same values as we used for input for the command. So let's log out the exterior light state. Good. Now we're missing a button. And connect it up. Okay. But I feel like lights isn't enough. Well, let's see, let's test it first. So, tap is building. It's launched. We'll start broadcasting successfully. Find our device, pair it. This time we don't have to authorize it because it's already authorized, as you can see here. And so let's press the turn on lights button. And the lights turned on. And in the console we can see that the front light state is now active with full beam. Okay, perfect. Next thing to do is let's add a trunk command. No, let's add a label first. so we can see some feedback in the app so that we don't have to look at the console. Now, let's go to the storyboard. Add a little label here. Connect it. And I'm just gonna clear the text and make it a little bit bigger. Perfect. Now that we have a label that we can display some text on, let's go to the parse command, parse method, and let's rewrite some of it. So another nice way to handle the incoming Auto API commands is using a switch. Okay. And let's add the lights parsing. Simple. And let's update the label with the same thing we logged to the console. Yes. Excellent. Now that we've done that, I'll add a few more. Patience, response. So what can I add here? Let's use the text. And let's add a trunk as well. So for the trunk, let's print out position, and noted. I know that it has a lock state as well. Lock. Perfect. Furthermore, I want to automatically send a command to lock all the doors when the trunk is closed and locked. So let's do this. So if it's closed and if it's locked, yes. Then we'll send the door locks command. To do this, we're gonna need the authenticated link again. Just copy that. And we'll need the bytes for the command. So, what does it need? Lock values. This is just an enum. Okay, simple. Now, as we remember, the send command throws. Let's just copy it. Good. And change this. Okay. So now, if we receive the trunk is locked and closed, we will also lock the doors. Just let's want to give it a little delay. So we'll give it 1 second to read. Okay, so let's run that. It's okay. Now let's start broadcasting. Connect it to the emulator. Excellent. And let's find the trunk. So let's open it. Okay. As we can see, we have some text in the app, but we obviously made the font too big. Anyway, let's close the trunk and lock it. And as we saw, the doors on the car locked as well. Good. The next thing we would like to try is to see the telematics connection. To do this, we'll first implement a function called download access certificates or certificate. So besides the local device, there is also a telematics class that we can use to send telematics commands. So here's the telematics method for downloading access certificates, and as you can see, it needs the access token. For that, you have to go back to the developer center. We'll go to the Develop tab, Services, and we'll create a new service. We'll choose My App of the car app. Full access, and I'll create it. Let's just make sure the app is correct. My app, it's not. So we have to connect it to my app. Okay. My app, full access. Okay. So now we created the service. We have to go back to the car. So this is the car we created before. We choose it. We'll go to Connect Services and we'll select our sample service. We'll enter the workflow to connect it to the car. Yes. And we'll copy the access token. This can also be accessed from the authorized services column, and here's the full snippet. Okay. Now that we have the access token, we can input that in the access certificate download. And continue with our implementation. This is also a throwing method. Okay. Again, I prefer to use a switch. And the result is a simple enum that has two values. Failure, that returns a string with a failure. We just print it out. And the other case, success, that it will read the documentation for this method. This returns the vehicle serial. Now this is important. It's important because we need to save the vehicle serial to send the commands later. Let's first save it, and then we'll see later how we'll use it. So Okay, now we'll have the vehicle serial. And we'll download the access certificates after we've initialized the local device. So this is always mandatory. You can't download the access certificates without first having been initialized the local device. Mm-hmm. Okay. And the last thing to do to test the telematics, let's add a function to flash the lights. So previously we needed the authenticated link, but because now we're using telematics, we need the vehicle serial. Let's make sure we have it. And let's find the bytes for flashing lights. So, as you can see, this returns optional bytes. Don't want to honk the horn, let's flash the lights 3 times. So if this is optional, let's guard it. And we have the command bytes, we have the telematics vehicle serial. Now we'll just have to send the command. Again, it throws. So we'll input the bytes, the serial, and this is the completion flow. This is almost identical to the download access certificates completion block, with a minor difference that the success is we'll see in a minute. Reason. So let's be lazy and copy this part. Another one. So this returns the response for the command. But the difference here is that this can be an optional. So let's make sure there is data. And if there was some data, let's send it to our parser. Because we made a generic before, then we can input data there as well. Okay. So we're sending lights command, then it would be wise to have a parser for it as well, or some feedback in the UI. turns out it doesn't have a response. Okay. So we need to finally create a button for it. Okay. Let's run that. And this time, because we're using telematics, so we don't have to start broadcasting. So you can just tap the flashlights button. And it worked. So it showed us failed to parse as an auto API command. That is because the response from honk horns and flashlights is an empty one. That means that the vehicle received the command, but it had nothing to respond to. Let's try again. Empty response, and the lights are flashing. Okay, that wraps it up. Thank you for watching. If you have any questions, we're in the forum and on Slack. Good luck to all in the challenge, and goodbye.